What is cloud computing? Cloud computing is on-demand access via the internet to computing resources, applications, servers, physical servers and virtual servers, data storage, development tools, networking capabilities, and more hosted at a remote data center managed by a cloud services provider. Cloud computing helps do the following. Lower IT costs. Cloud lets you offload some or most of the costs and effort of purchasing, installing, configuring, and managing your own on-premises infrastructure. Improve agility and time to value. With cloud, your organization can start using enterprise applications in minutes instead of waiting weeks or months for IT to respond to a request, purchase and configure supporting hardware, and install software. Cloud also lets you empower certain users, specifically developers and data scientists, to help themselves to software and support infrastructure. Scale more easily and cost-effectively. Cloud provides elasticity instead of purchasing excess capacity that sits unused during slow periods. You can scale capacity up and down in response to spikes and dips in traffic. You can also take advantage of your cloud provider's global network to spread your applications closer to users around the world. Cloud computing services. SaaS, Software as a Service. SaaS, also known as cloud-based software or cloud applications, is application software that's hosted in the cloud and that users access via a web browser, a dedicated desktop client, or an API that integrates with a desktop or mobile operating system. In most cases, SaaS users pay a monthly or annual subscription fee. Some may offer pay-as-you-go pricing based on your actual usage. PaaS, Platform as a Service. PaaS provides software developers with on-demand platform hardware, complete software stack, infrastructure, and even development tools for running, developing, and managing applications without the cost, complexity, and inflexibility of maintaining that platform on premises. IaaS, Infrastructure as a Service. IaaS provides on-demand access to fundamental computing resources, physical and virtual servers, networking, and storage over the internet on a pay-as-you-go basis. IaaS enables end users to scale and shrink resources on an as-needed basis, reducing the need for high, upfront capital expenditures or unnecessary on-premises or owned infrastructure and for overbuying resources to accommodate periodic spikes in usage. Types of cloud computing. Public cloud. Public cloud is a type of cloud computing in which a cloud service provider makes computing resources anything from SaaS applications to individual virtual machines, VMs, to bare metal computing hardware, to complete enterprise-grade infrastructures and development platforms available to users over the public internet. These resources might be accessible for free, or access might be sold according to subscription-based or pay-per-usage pricing models. Private cloud. Private cloud is a cloud environment in which all cloud infrastructure and computing resources are dedicated to and accessible by one customer only. Private cloud combines many of the benefits of cloud computing, including elasticity, scalability, and ease of service delivery with the access control, security, and resource customization of on-premises infrastructure. Hybrid cloud. Hybrid cloud is just what it sounds like, a combination of public and private cloud environments. Specifically, and ideally, a hybrid cloud connects an organization's private cloud services and public clouds into a single, flexible infrastructure for running the organization's applications and workloads. Cloud security. Security concerns have been the primary obstacle for organizations considering cloud services, particularly public cloud services. In response to demand, however, the security offered by cloud service providers is steadily outstripping on-premises security solutions. Shared responsibility for security. Generally, the cloud provider is responsible for securing cloud infrastructure and the customer is responsible for protecting its data within the cloud, but it's also important to clearly define data ownership between private and public third parties. Data encryption. Data should be encrypted while at rest, in transit, and in use. Customers need to maintain full control over security keys and hardware security module. User identity and access management. Customer and IT teams need full understanding of and visibility into network, device, application, and data access. Collaborative management. Proper communication and clear, understandable processes between IT, operations, and security teams will ensure seamless cloud integrations that are secure and sustainable.